And there's a lot of ways you could work this problem. You could go straight to what you just commented on. You could look at it and say, okay, f of x is a straight line. G of x, maybe you're not sure, but G of x is a straight line. You know, you might not be sure about G because of that division, but they're both straight lines. They're not horizontal lines. You could go at it like this and say, you know what, let me just find the inverse. So I want you to notice different ways that I'm going to work this problem. I could say, well, let's find the inverse of one of them. I'll do f of x. And if it matches G, then what's your answer? Yes. If it doesn't match G, no. There would be the answer. So I'm looking at f of x. I'm going to say, okay, let's change f of x to y. Y equals 6x minus 18. And then I need to trade the x and y. So x equals 6y minus 18. Solve for y. There's my x plus 18 equals 6y. And then x plus 18 divided by 6 is y. So you could reduce. I think I will. I could split this into two fractions, because if I had two fractions and I had a common denominator and I combined them into a single fraction, I could go the reverse way. This is something important for you to know as a teacher. And I'm going to say math teacher, but I know y'all are going to be teaching what? All sorts of stuff. So as a math teacher, I want you to know this. Let's say I have two fractions and they have a common denominator. So I add the two fractions and put it over the common denominator. This step of putting them together is just as valid if I went the other direction and I wrote it as two separate fractions instead. So part of the reducing, I'm going to just write it as two separate fractions. 18 over 6 is what? Is 3. That's the inverse. And it looks a little sneaky, because f had this. F had minus 18. But this has plus 3. But the difference is kind of the order that we might have done the operations. Because here I'm multiplying by 6 and then adding 18. Here I'd be dividing by 6 and then add 3. And that what's 6 times 3? There's your 18. It's sort of disguised in there. And this is why some of those puzzles I've been sort of referring to, I'm kind of interested in investigating that a little bit more. But those puzzles where pick a number, do this, do that, blah, 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 you got the same number you started with, because maybe they had something like, you know, add 3, subtract 18 after you did some division, add 3, and it's disguised.
So it's not inverse.
These two are not inverses. Thank you for getting me back on track there. You are absolutely right. These are not inverses of each other. Not inverses of each other. Now suppose you had a student who did this, because what's going to happen when you're a teacher, Your students are going to work problems all sorts of ways. And then you're going to have to determine. Wait a minute. On the key I wrote this, but my student took a totally different approach. Is my student still correct? What y'all think of those teachers that might have said this? You work it my way or it's wrong. Y'all ever had a teacher like that? Okay. You work it my way or it's wrong. I don't know. Okay. That'll have to be your call in your classroom. I'm not quite a fan of that. Okay. I feel like I just got on a soapbox. Let me get off.